All right, everybody. We are going to round up, finish off, wind down our review, our recap. We are going to finish off the more important parts of Algebra 1. Again, this is going to be a whirlwind pace. Hopefully it's review. If it's not, check out another YouTuber out there. There's so many talented, far superiorly competent mathematicians than myself. Plus, they got much better production skills than these videos. So if you need a deeper review of the material, go ahead, check out another YouTuber and give each of these subtopics their due. Make sure that you grasp them. But what we're going to start off with, we finished off with 1 and 2 step equations, solving for a variable. Now, solving for a variable algebraically was a big part of Algebra 1. I certainly didn't do it justice. Definitely deserves a lot more practice and delving deeper. But this is a review portion. We're just chugging along to Algebra 2. So we're going to go right ahead to two variable equations. The most popular variables generally for these two variables, the standard two variables, are y and x. Y is equal to x. That right there is a relationship. That's a linear relationship. We're talking about equations here, right? There's an equal sign. We're talking about equations here with two different variables. No longer is it a number and a variable. It's two different variables. And there's an infinite number of solutions. Ironically, even though this is kind of a simple one, this one's actually a little confusing. I'll show you guys another example after this, and you'll see what I mean. Now, here's how you got to think about it. You make up a little XY table here. And the way that you solve this is you plug in any number, any real number in the whole world that you want for x, and you see what y is equal to. -7. When x is -7, y is -7. Okay. How about when x is 0? When x is 0, y is going to be 0. One more example, although it might be overkill. When x is 2, what's y going to be? When x is 2, y is going to be 2. This linear relationship is a one-to-one relationship. It's not actually that helpful in helping you guys understand the value of, at least the way I'm describing it. Someone else could probably do it better. To help you understand this, the concept of linear relationships. We're going to have a visual representation of that in a second. But let me show you another one that I think will make more sense. Set up our XY table again. Now, when I plug in a value for x, say -1, y is going to equal 2 times -1, or just -2. If I plug in 4 for x, y is going to equal 2 times 4, or 8. Y is going to equal 8. If I plug in 25 for x, y is going to equal 2 times 25. So y is going to equal 50. As you can see, for every 1 of x, there will be 2 of y. That's all that relationship is showing us. I'm going to show you just one more, and then I'm going to start graphing these relationships. These two variable relationships can be visualized in the form of a line. You guys are going to see how in a second. But I want to give you one more example first. Y is equal to -3x. Once again, let's make our XY table. I'll pick a few numbers. I'll just pick 2. -2 and 5. When x is -2, y is going to equal -3 times -2. A negative times a negative is a positive, so I'll be left with 6. All right, when I plug in 5 for x, y is going to equal negative 3 times 5, or 15. Or sorry, negative times a positive is negative. Just a little recap of this too. A negative times a negative is a positive. A negative times a positive is a negative. A positive times a negative is a negative. And a positive times a positive, as you guys well know, is a positive. If that's too much review, sorry, couldn't help it. Couldn't resist. It's going to come in handy. Multiplying negatives and positives happens a lot, and it's important to know. But all right, we've got y is equal to negative 15 when x is equal to 5. Now these points as they're called, coordinate points on a two-dimensional space. I'm getting ahead of myself. But these points can be written out like this. Negative 2, 6, 5, negative 15. And in both of those cases, this side is the x value, this side is the y value. You always do the x first, and then the y. But now that we've had a few of these examples, I want to show you what they look like graphed. Let's go back to our basic linear relationship, the one that I started with, because graphically I think it actually gives a good example. We're going to graph on a two-dimensional plane, a 2D plane, a two-dimensional plane. That means you can go this way, you can go this way. You can go this way, you can go this way. But this graph is not going to pop out of the paper and come at you. It's only two-dimensional. It goes left and right, that's the x-axis, and it goes up and down, that's the y-axis. This is known as the xy plane. It's just a two-dimensional plane. It's also known as the Cartesian plane, named after René Descartes, famous French philosopher mathematician from a few centuries ago. But let's not get into that. Let's get into graphing our equation in a 2D spot, in a 2D space, in a two-dimensional plane. We have y equals x. Now remember, for this one, this is our basic relationship. Our xy, you're going to have, pick a random number, negative 7. When x is negative 7, y is negative 7. And 4. When x is 4, y is 4. Now I got to make sure that I keep this proportional, so I'll go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 5, 10, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 10, 5, negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5, negative 10, negative 5, and negative 1, 2, 3, 4, 5, negative 1, 2, 3, 4, 5. I have labeled, perfectly labeled my axes, constructed my plane. I am ready to put my coordinates in. So let me write these in the point form. This is going to be negative 7, comma, negative 7. And this one's going to be 4, comma, 4. So let's see, negative 7. Remember, I always do my x first. So I'll go 1, 2, 3, 4, 5, 6, 7 that way. And then 1, 2, 3, 4, 5, 6, 7 there. That's my negative 7, comma, negative 7. And then my other point is 4, 4. Go 1, 2, 3, 4. I always start at 0 here. I start at my central hub here of 0, 0. And I go 1, 2, 3, 4, and then up 1, 2, 3, 4. Right there. And then I'll use a straight edge to draw my linear relationship. Maybe now you guys can see why I keep on calling it a linear relationship. I'm not trying to be punny. That's just what it's called, because it can be represented graphically as a line. Let me give you another one, except this time I'm not going to give it to you in this traditional way that I've been given to you. I'm going to throw another wrench into the gears. let's graph y equals negative x plus 3. Y equals negative x plus 3. So using my table method, I'll plug in a couple points for x. I'll go with, let's go with negative 1 and 5. When x is negative 1, y is going to equal negative times negative 1 plus 3, or negative times a negative is a positive. So 1 plus 3, so y is going to equal 4 when x is negative 1. When x is equal to 5, y is going to equal negative times 5 plus 3, or negative 5 plus 3, also known as negative 2. So when x is 5, y is negative 2. Let me put these points and label them in point form. Let me put them on the graph. Negative 1, positive 1, 2, 3, 4. 5, negative 2. So that's going to be negative 1, positive 4. That's my x, that's my y. It goes to the left. Negative 1 on the x, positive 4 on the y direction, and the up and down. My other point is going to be 1, 2, 3, 4, 5, negative 1, 2, negative 2. All right, right there. That point is 5, comma, negative 2. Once again, I will connect these two. Nice, nice. Come on. And that is a linear representation of this equation. Now, I'm going to gloss over this. I keep saying this. I've said this a lot. I'm not doing justice to any of these topics. This is just a fast review that I need you guys to be able to have available already in the front of your mind when we jump into Algebra 2 stuff. So this is a fast review. I'm not doing it justice, but do your best to ask me questions if you need me to cover any of these in greater depth. Or Google it and find your own YouTuber that you prefer, or someone who covers it in more depth, because I am going quickly. Last bit is just a different notation, function notation. This equation, this two-variable equation, y equals x, can actually be expressed in a different form. My name is Mr. Sam. My last name is Ruchnick, so my name is also Mr. Ruchnick. I am Mr. Sam, and I am Mr. Ruchnick. That's the same person. You're describing the same thing. I'm saying the exact same thing when I call this f of x is equal to x. That's function form. Function form. Instead of saying y is equal to x, I say f of x is equal to x. It's a function. F. I'll get into that in a second. And, of course, over here, same thing. I can make up a different function, let's say g of x or h of x. It doesn't matter. Go with h of x. H of x here is equal to negative x plus 3. This is the same thing as saying y is equal to negative x plus 3. It's just a different form. And honestly, I kind of like it. And I'll explain to you why. Functional form, in my mind, makes more sense. You got your h of x. This is the function h. The relationship, the linear relationship in this case, h. And that's equal to negative x plus 3. Remember, this is the same thing as saying y is equal to negative x plus 3. This is just a linear relationship. Why I like this is because I like the visual of knowing every time I plug something in for x, I can write it there, and then it'll pop up there. Let me show you what I mean. I'm trying to make my table, right? I got my x, y, table here for a couple of points. Let's go with -3, 0, and 1. So what is my h of -3, or when x is -3, what is h of -3 as it's said? Well, anywhere I see an x, I plug in a -3. Negative times a negative is a positive, so that's going to equal, well, it's going to equal 3 plus 3, which is equal to 6. So h of -3 is equal to 6. H of 0, when you plug in 0 for x, -1 times 0 plus 3, anything times 0 is 0. So h of 0 is just 3. And lastly, h of 1. H of 1 is equal to negative times 1, or -1 plus 3. -1 plus 3 is 2. So h of 1 is 2. The reason why I like this form, the reason why I like function form, is because I like to visualize that this function takes something, takes some number, it plugs it into this machine, like a sausage machine. You put the meat in the top of the sausage machine, you push the meat in, out comes the sausage, right? Well, this X right there, that is the hole to put the sausage meat in. You plug in the meat right there, and you plug it in for every value of X that you see in your equation. Out comes this different value. You plug in -3, out comes 6. You plug in 0, out comes 3. You plug in 1, out comes 2. All right, let's see. We've already graphed this one. I was just showing you guys a different form. Instead of having y equals, this is functional form. Let's do one last thing, and that is slope-intercept form. There's actually a couple of linear shortcuts, and there's absolute value, which we're not even going to touch. We're not even going to touch inequalities. There's a whole bunch of stuff from Algebra 1 that we're not going to touch. But I think it's important. There is one particular form of linear equations that is standard, if you will. It's standard because it tells us a lot. It's fun to work with. Now, you'll get linear equations, two variables. You'll get two variable linear equations that look like this. You'll get linear equations that look like this. You'll get linear equations that look like this. The variables can be all over the place, but the most common, the conventional way, the form that you'll be given a linear equation is in this form, in slope-intercept form, which is y equals mx plus b, where m and b tell us something very specific. Now, remember, this y and this x, these are our variables. This y here and this x, they are our variables. We're going to plug in different things for them. But we've seen different equations like y equals 5x plus 1, y equals -2x minus 7, y equals -3x plus 11. These are all examples of slope-intercept form, of lines, linear equations in slope-intercept form. And you can rewrite it in functional form too. It'll still be slope-intercept form, just in functions. F of x is equal to this. G of x is equal to this. H of x is equal to this. But what is M and what is B? M is your slope. Your slope is how steep a line is. If you're going off a ramp, you're like, oh man, that's a sick ramp. But that ramp, oh, that one's gnarly. You're really going to get some air on that one, bro, right? The slope is just how steep something is. So the slope can also be described as how big the up and down is compared to the left and right, or the change in the up and down, the change in the y-axis compared to the change in the x-axis, or more informally, the rise over the run. So given some line, what is the rise, given some line, 2 points on that line, what is the rise here and the run there? It's a right angle. The rise over the run will give us the slope of this line. If you got y is equal to 2x plus 0, it's just 2x. The slope here is 2 over 1. Every number is over 1. You divide by 1, it doesn't change the number. So y is equal to 2 over 1. The rise is 2. You're going to go up 2 from this point, and then you're going to go over 1 there. You're going to go up 2 to there, and then over 1 to there. You're going to go up 2 to there, and then you're going to go over 1 to there. And then you can connect those points, and you'll see that the slope of this line, pretty close at least, the slope of this line is up 2 over 1, up 2 over 1, up 2 over 1. So m is the slope. B is the y-intercept. That tells us where our line goes through the axes. So I'll give you one example, because then we do have to push on. Maybe I'll give you 2 examples. How are we doing on video time? It's a long video compared to the others. We'll see how we do. Let me give you this as the function. Y equals 2x plus 3. So what does that tell us? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 2, 3, 4, 5, 6. Just labeling. Maybe I'm over labeling, but whatever. Better safe than sorry. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 1, 2, 3, 4, negative 5. Okay, this is telling us that our y-intercept, it intercepts the y-axis at 3. That point is going to be 0 left and right, so 0 for the x, and then positive 3 for the y. And it also tells us our slope. It tells us that this line will go up to, over 1, right there. Up to, over 1, right there. Up to, over 1, right there. So I plotted 4 points. You only need 2 to make a line. Given the slope intercept form that I was given this equation in, I can then plot this line just like that. Let me give you guys one more example. Now, you guys remember that table method? We don't like to use the table method. Generally, when we look back on algebra, we almost always revert to our point slope form because it's just so easy to use. We don't have to plug in any points. You plug in the 1 point, the y-intercept there, and then you plug in the slope, and you go up or down from that point, and you knock it out that way. Let me give you another one. y is equal to negative 3x minus 1. All right, this time my y-intercept is negative 1 right there. And my slope is going to be negative 3. This is technically over a 1. Every number can be divided by 1. It doesn't change it, so we can do it. Negative 3 divided by 1. So that means rise over run. The rise is negative 3. It's actually a negative rise, negative 3, so it'll go down 3. And then over run, the run is positive 1, so it'll go to the right, 1. So down 3, 1, 2, 3, over 1. Down 3, 1, 2, 3, over 1. Okay, this is a little steeper, which makes sense. The slope is a little steeper. And it's negative. All right. That right there is my other y equals negative 3x minus 1. That is a visual representation of this, and the green line is a visual representation, a graphical representation of that. Lastly, before I end this video, what is the equation or the function of the following line? I'm going to give you 2 points. I want you guys to tell me the equation of the following line. There's a point there, and there is a point there. So the points are negative 5, 0. And that point there is going to be left and right is 0. So negative 0 on the x and up 5 on the y. Bring y'all in a little closer. All right, let me plot this puppy. There's that blue line. What is the slope? What is the y-intercept? What is my linear equation for blue? What is my f of, I'll stick with y to not confuse anyone any further. It's already a new concept that I'm throwing into this. Y is equal to some slope times x plus or minus some b. Well, what is the y-intercept? This line, it goes through y at 5, so this is actually plus 5. And the slope here is going to be, let's see, from this point to that point. Let's see, we go up 5. The rise is 5. And then we go this way. We go to the right, also 5. Well, looks like our slope is 5 over 5, which reduces down, because any number divided by itself is 1. So this reduces down to y equals x plus 5. All right, that has been your recap in algebra. Look forward to a systems of equations video as our next sort of segue into algebra 2. It's going to be a little bit more in depth, but I know you guys can handle it. You guys are awesome. Thank you. Appreciate y'all. Cheers. See you next time.